Taking a look at this example, it says the length of human pregnancies from conception to birth varies according to a distribution that is approximately normal with a mean of 266 days and a standard deviation of 6 days. Choose 2 pregnancies independently and at random. What is the expected difference in the lengths of the 2 pregnancies? So when I think about this, what I'm going to have is I'm going to have the expected value of x minus y, which is the expected value of x. Again, I'll put this in as a note. This is the expected value of x minus the expected value of y. Well, the expected value of x is 266 minus the expected value of y, because it is an independent random variable, means that the outcome of the first pregnancy has nothing to do with the second, so it's also 266. So the expected difference in the length of the 2 pregnancies is 0. Okay, well that's nice. So I'm going to leave that up there. And then the second question says, what is the standard deviation of the difference of the length of the 2 pregnancies? Well, in order to do that, I have to first think about the variance. So I'm going to do the variance of x minus y. And the variance of x minus y is going to be the variance of x plus the variance of y. Okay, well, what is the variance of x? The variance of x would be the square of the standard deviation. So it says that it has a standard deviation of 16, so I'm going to do 16 squared. That is the variance of x, plus the variance of y, which is also another 16 squared. So this variance of x minus y is 512. So what is the standard deviation? SQRT, the square root of 512. So the standard deviation of this random variable is 22.627. So that means that these normally distributed births are going to have if I have 2 randomly chosen births, they're going to have a mean difference of 0 days, but they will vary by 22.6 days on average. So then when it asks me to find the probability that the difference in the length of 2 days is greater than 25 days, all I have to do is a normal distribution. So normal, DIST, the mean of this we found was 266 minus 266, which is 0. And the standard deviation is this 22. So what I can do is I can just copy and paste that number right in there. So I just Control C and Control V, just copy and paste that thing in there. Let's zoom fit so I can see what this thing looks like. There's what it looks like as a distribution. And I want to find the probability of greater than 25 days. So I'm going to bring this up. Because I want greater than, I want a right tail. And I'm looking for a probability of when x is greater than, I put in 25 for 25 days. And the area to the right of 25 is 13.5%. So what is the probability that the mean difference in the lengths of the 2 pregnancies will be greater than 25 days? Is 0.135. Let me think. What if I wanted to do... I guess I could probably do a negative 25 on this as well. I could probably do an outer. And I could go negative 25 and 25. Actually, I think that's going to be a little bit better. That way, if I have the first pregnancy is longer than the second pregnancy, or the second pregnancy is longer than the first pregnancy. That way I can actually find both tails. So I can think about those pregnancies as a negative 25 day or a positive 25 day. So I actually want to take a look at both of those bounds. So I would say that the probability for the difference in the lengths of the 2 pregnancies greater than 25 days should be 26.9%.